In this episode, I start to apply the genetic algorithm on the Lightgreen capsules and try to teach them to reach the target, which will be the red ball. At the end of this video, each of them will get a fitness value based on their distance from the target point. Okay, what I have so far is an array of 3 smart cups. They get a sequence of 100 steps put in their brains. This make move method iterates through those steps, and when it reaches the end of the array, the cups stop. On the canvas, it looks like this. Now I want to implement the genetic algorithm on these capsules so that they can learn how to reach a specific target. But before starting that, I would do a preparation step, which would be adding a relaunch button for the capsules next to the canvas, so that instead of refreshing the page after they stop, I can click on that button to make them start moving again. That will require a little HTML. So in the index.html file in the beginning of the body tag, I create a div element, add a little styling to it, float left, border 1 pixel, solid black, and inside of that div there will be a button with the ID of relaunch, and the text will be new start. In the game template, I grab that button element with the get element by ID, and this whole initialization block will go inside of the starter button.onClick. Counter will be set to 0 once the button is clicked, and step counter as well. Let's check what has changed. The button is there, and if I click on it, the capsules start to move on the canvas. So far so good. Now what if I click again? New capsules keep coming, but the old ones don't disappear. That's because the old capsules are still part of the physics engine, and I need to remove them myself. To remove a body from the physics engine, every body has a remove method implemented. So in the onClick, I can say that if a smart cups with a specific index already exists, then please remove it from the physics engine. Now whenever I click that button, the current capsules disappear, and 3 new capsules start moving around. And at this point, it's finally time to implement the genetic algorithm, first by initializing a population of smart cups. The population of capsules won't be stored in a simple array like now, because it's more complicated than that. I will create a population class instead, which will have its own properties and methods. So I go and create a new file, smartcupspop.js, and a new class inside of that. In this class, the members of the current generation will be stored. So let's start with an empty array in the constructor. And I also define an init method that will instantiate 3 smart cups and create their steps, 100 steps again. Of course, I need to import this new file as well in the index.html after the smartcups.js, otherwise I cannot use the smartcups objects in the population class. And in the game template, I create a new smartcupspop object instead of the array. And here in the button onClick callback function, I simply need to call the population object's init method. And that would mean that I don't need this block anymore, although I do need to use this condition with the remove in the init method as well, because the capsules still need to be deleted if I don't want them to be displayed. And finally, in the game loop, the iteration will happen through the cups array of the smart cups population. And I had a typo here, this is a capital S. I check the canvas. If I click on the button, I can see 3 capsules. They look the same as before, but this time they are not individuals anymore. Each of them are now members of a population, which is a big difference. Very good. Now that I have a population class, I can start the initialization. For example, if I want the size of the population to be a property as well, one that comes as an argument when the population is created, then I put a pop size between the constructor's parentheses. That will be the value of the pop size property. And that value will be in the for loops condition as well. And that's all. Now if in the game template I put 20 as an argument, go to the canvas, click on the button, then boom, 20 light green capsules are moving around on the canvas. So from now on, I can easily change the population size. I mentioned earlier that there will be a target point, and that the capsule's task, the purpose of their lives, will be to get as close to that target as possible. The position of this target point will be a vector defined in the population's constructor as target point, and it can be any point inside or outside of the canvas. I set it to 500 and 100 so that it will be near the top right corner. If I want to display it, I can create a new ball in the game template with a target points X and Y values as its position. I set the layer to -2 so that it won't collide with any other bodies of the physics engine, and its color will be the good old red. And here we go, the target is there. Of course, it doesn't have any features yet, except for being visible, but that's already better than nothing. Now that I have a target point property in the population class, I also create a starting point property, another vector, so that I can easily change the capsule's starting point if I want to. Let's change that starting point to 100, 400, so that they will start from a bit further away from the target point. And I call the constructor with starting point x, y plus 10, and x, y minus 10, like that. And go back to the canvas again. Alright, next, they will need to learn that being close to the target after stopping is a good thing. And the best way to tell a capsule that it did a good thing is giving them a high fitness value. After they stop, each capsule's distance will be calculated from the target point, and the closer they are to it, the higher that value will be. Now for the distance, the lower the better, while for the fitness value, the higher the better. And to resolve this paradox, the fitness value will be inversely proportional to the distance. Let's say fitness value equals 1 over distance, something like that. So first of all, I want the distances to be calculated once the capsules stop moving, for which I'm going to create a method in the population class that adds all the velocities together, or in other words, it returns with the sum of the capsule's velocity vectors magnitudes. Then let's check this value out. If I console.log it in the game loop to see it in every iteration, and then open the developer tools, I can see that the sum of the velocities is more or less constant for a while, and then suddenly drops. And I don't want to wait until this value reaches exactly 0, but what I can do, and is almost as good as that, is setting a condition for this value right there. If the sum is less than 0.01, that's when the fitness values need to be calculated. To see this working, I disable the button when it's clicked and enable it back here, so that I can only restart the capsules when they are slow enough. Plus, in this case, I need to add step greater than 0 to the condition as well, because in the very first step, the capsules are not in motion yet, but I still don't want the button to be disabled yet. Then here is the canvas again. I click the button, which makes it disabled, and at the moment the button becomes enabled again, that's when the fitness values will be calculated. First, I will need the distance between the capsule and the target point. Calculating the distance between 2 points, A and B, is getting the magnitude of the difference vector between them, the magnitude of A minus B. So in the SmartCaps class, this time not in the population class, I create a distance method. The argument is a vector and it returns with the magnitude of the vector that points to the capsule's position from the given vector. These vector operations are defined in the physics engine. This means subtraction and this means magnitude. And the capsules will also have a fitness property. Default value is 0, and they will receive a new value from the population class when the time comes. Let's define then a setFitness method in the population class, where I can just iterate through all the capsules in the current population and set their fitness value to 1 over distance from the target. Plus, I want to see those values, so I console.log them out as well. And I call this setFitness method in the condition for the balls being slow enough right after enabling the button. Check the canvas, run the capsules, wait until they slow down, and the fitness values are displayed there. I really don't like that they are being recalculated over and over again when the capsules are not moving, so I create a global boolean variable. Caps are moving, initializes false, and when the button is clicked, it will be true. And later when the capsules stop, it will become false again, and everything in the game logic will only run if the caps are moving variable is true. If I launch the capsules again and wait until the last step is reached, when it displays the fitness values, they will be displayed only once. They are very small numbers, so I multiply them by 1000 inside of the setFitness, just because I think that looks better. And give it another try. And let's try to find out which capsule gets which fitness value. Yeah, so I cannot really check it, but it's safe to assume that this one with the 11 is the one that is the closest to the target point, and probably the 9 is the second one. It's really hard to tell, but it's an educated guess. And you can probably see now where this is going. I have the fitness value of each member of the current population displayed here. The next step will be implementing the selection algorithm based on these fitness values. I will do that in the next episode. I want to cut this implementing the genetic algorithm process in half so that the video won't be so long. Hope it's okay. So see you soon.